Hello, puppets! We are back at it again with another math video. Your quarterly, day 2 is tomorrow. These questions are just like them. Pay attention, don't skip, see it through. Number 1, write the first 5 terms of the recursive sequence. So we know that our first term, by the way, we're on Smart Notebook again because that app is still not on my iPad. A sub 1, that means first term is 1. A sub 2, well, this is the hard part. We have a pattern somehow. This says to take 2 first, and A sub n minus 1 we know means the previous term, p term. It means the previous term. Oh wow, that went well. The previous term. So we're going to take the previous term, multiply that, raise it to the second power, and then add 2. All right, so the previous term we can see is 1. So that's what's going in the parentheses. So now if you just put that right in your calc, you're going to get that the next term, I believe, is, oh my God, 4, and it's 4. I needed to consult my answer key. So 4 is the value of A sub 2. Now, if we want to find A sub 3, we're going to start with this pattern. Start with the pattern, but we're going to take the previous term, the second term, which was 4, and we're going to plug it in. And you put all of this in your calculator, and we're going to get 2314. Fourth term, 2 times 2314 squared plus 2. That is going to be, your girl was looking at the answer key and she was a little ahead. So the third term is actually 34. Some of you are probably like, that makes no sense, Miss Heschel, what are you talking about? So the third term is 34. Then for the fourth term, you're going to plug in 34, and then you're going to get 2314. All right, and for the fifth term, you're doing the same thing. You're plugging in 2314, and you're getting 107 091 94. So that is 10,709,194. Okay, so your first 5 terms are 1, 4, 34, 2314, and 10,709,194. Okay, so these are your first 5 terms. Know it, live it, love it. I'm just putting the commas. I feel that's important. You got to know what the actual numbers are. All right, so that's the first one. Dylan has a bank that sorts coins as they dropped into it. All right, the panel on the front displays the total number of coins inside as well as the total value of these coins. So we got 90 coins in total and a total of $17.55. All right, Dylan is only collecting dimes and quarters, so we got some D and Q. So we're going to let D be the number of dimes in the bank, and we're going to let Q be the number of quarters in bank. Ooh, number. Okay, so now that this is blocking most of the question, let's move this out of the way. If Dylan only collects dimes and quarters, write a system of equations in 2 variables or an equation in 1 variable that can be used to model the situation. So we have first equation. Excuse me, guys, I'm sleepy. We know there's 90 total coins here. So between the number of dimes, D, plus the number of quarters, Q, we should have 90 coins. All right, so that's the first one. Now, what are we going to do with 1755? What are we going to do with it? I bet you know, because you're so smart, you already know that a dime is 10 cents and a quarter is 25 cents. So this, bam, bada bing, this is your answer for the first part. Now it says, I'm using your equation or system of equations, which we're going to copy, woo, and paste down here, because times is tough, you know. Too hard to write these things these days. We're going to group it up, make it a little bit smaller. Determine algebraically the number of quarters Dylan has in his bank. So if I want to solve for Q, that means I want to eliminate D. So you're first going to eliminate D. How do we do that? Well, you're going to multiply the top by something that's going to cross out with 0.10. So you're going to multiply the top by negative 0.10 and distribute that throughout. So now this is going to be negative 0.10D minus 0.10Q, because we're just distributing. Use your calculator. This is going to be negative 9. So now these D's cancel out. And 25 cents take away 10 cents is 0.15 Q. And we have 9 minus 1755. That's going to be 855. Right, divide by 0.15. And the number of quarters should be 57 quarters. And if you were feeling frisky, you could figure out that the number of dimes, D, is actually 33. But they didn't ask you for that. They asked you for the number of quarters. So Dylan has 57 quarters in his bank. How cute. How much money is that? How much money does Dylan have? Oh, 57 times 0.25 is about $14.25. So don't spend it all in one place, Dylan. All right, next question. All right, Carl has a job for X hours a week after school that pays $8 an hour. All right, he's accepted a job that pays $12 an hour as a landscaper working Y hours per week. He will work both jobs. He is able to work no more than 20 hours a week, and he wants to earn at least $108 a week, working a combination of both jobs. Okay, so write a system of inequalities that can be used to represent the situation. So let's start with the inequality symbols. We have no more than 20 hours. We know that's going to be something. And we also know at least 108. He wants to earn at least 108 bucks. All right, so I guess we're going to say we're going to let X equal the hours after school. All right, and then Y, hours landscaping. All right. Just so you know. That's what we're working with here. So the hours between working after school and working landscaping, he wants to work no more than 20 hours. And he makes $8 an hour after school and $12 an hour landscaping. So this is your second. So these are both your equations. So we wrote the system. Now it says to graph the system. Now you guys know that you have to put it in y equals form. So I'm just going to write them on the side, and I'm going to do that one by one. So this is my first one here. I'm going to start at my y-intercept of 20, and my slope is telling me to go down 1 over 1, so I'm just going to make my point. And now you gotta start thinking about which way you're going to shade, because that is also important. I wish I would have done this. There's a lot of dots. So now we're going to connect these with a beautiful straight line. Oh yeah. Right, solid line because of that line underneath. And we're going to be shading it down because it's less than. Right, so I'm just shading. And let's do the next. So now just divide everything out. We brought the x over first. Now we're just going to divide everything by 12. So we have y is greater than 2/3 x plus 9. Now let's graph that. I have graphed it, and now I'm going to shade up. Whoa, a little crazy. Okay, so now it says determine and state one combination of hours that will allow Carl to earn at least $108 and work no more than 20 hours. Anything within this solution set, anything within this overlapping shaded area will satisfy both inequalities. So we could say possibly 8, 8, I think was the example I used in class today. That's right there. That falls right in the overlapping shaded area, which means it satisfies both inequalities. So we're going to say 8 hours at the, oh my gosh, after school job and 8 hours at the landscaping job. That's it. And it's yelling at me. I'm going to put a, oh, that didn't work either. Right there. Okay, so this is the one combination. You could pick anything that's in this overlapping shaded area. Ms. Somei has a rectangular picture frame, picture including a frame that is represented by 4x plus 3 in length and x plus 3 in width. Express the perimeter of the picture, including the frame, as a polynomial in standard form. Okay, so what you got to do is label this. This is going to be 4x plus 3, 4x plus 3. And this is your x plus 3. Now, perimeter, add up all the sides. Don't multiply it, add up all the sides. So that means we have 2 lengths and we have 2 widths. And we're going to add all this up. It's okay if you write it all out. If you write 4x plus 3 plus 4x plus 3 plus x plus 3 plus x plus 3 plus 3, it's the same thing. Now distribute. When you combine your like terms, you get 10x plus 12. Okay, so this is the final answer. Now, express the area of the picture, including the frame, as a polynomial. So this is where you do length times width. You're going to get 4x cubed, or squared rather, plus 12x. Right, you do this thing. Now 3x plus 9. You combine your like terms. So that is 4x squared plus 15x plus 9. So keep in mind, this is the area of the whole thing, including this little derpy face over here. This is the area of the whole thing. Now it says, what is the area of the picture including the frame when x is 4? Wherever you had x, you now have 4. So when you put this all in your calculator, you're going to get your answer to be 133. Okay, 133. If the dimensions of the picture without the frame is x minus 2 in length and x plus 4 in width, find the area of the frame only. So let's take all of this. Hold on. So basically, it's saying that this picture, the dimensions of the picture itself are x minus 2. We're going to make that nice and small. Just the picture. All right, this is x minus 2. And the other one is x plus 4. X plus 4. So I'm going to tilt the world that on its side because this goes here. So the picture length and width are x minus 2 and x plus 4 respectively. Now, find the area of the frame only. So this blue part. So what you really need to do, guys, is find the area of the little picture, all right? Because when you find the area of the little picture, this guy's gone. All right, you're going to actually find the area of this first. So we're doing length times width, x minus 2 times x plus 4. So we're going to get x squared plus 4x minus 2x minus 8. So the area of the actual picture is x squared plus 2x minus 8. Oh my God. 2x minus 8. Oh my gosh, this really isn't working right now. So this is the area of the little frame. Now, if you want to find the area of just the blue part, because you just want the area of the frame only, you need to take the area of the big frame, which we found up here was 4x squared plus 15x minus 9. You're going to do the big minus little. Big minus little. Ah, it's annoying. Everything's fine. You're doing the big minus little. So you're doing the big area of the picture frame, including the picture frame, all right? Oh gosh. So this whole thing. So what happens is when you take the big minus the little, you are subtracting this little area. So you're taking this little face, you're subtracting that out, and you're taking out this picture. You're subtracting the area of this, and what you're left with is the area of the frame. So you're just going to do this. We said that the area of the whole thing was 4x squared. 4x squared. Oh, we don't have an exponent key, so there we go. 4x squared. Bear with me. I'll say it one more time. 4x squared plus 15x plus 9. And you're going to subtract x squared. Oh, there it is. X squared plus 2x minus 8. And you guys know the drill when you're subtracting. You distribute and combine like terms. So this is going to be a -1 out front. Distribute that out. So you're going to do 4x squared plus 15x minus 9 minus x squared minus 2x plus 8. So let's combine like terms. So in standard form, the area of the frame will be 3x squared plus 13x plus 17. Because this is 3x squared, this is 13x, and this is positive 17. And when the area of the frame is in standard form, what is the leading coefficient? Standard form, leading coefficient is 3. All right, so guys, study hard. This video is here for you. I'll be here in the morning, most likely, a little bit early. Okay? So come on by if you need to. Have a good night.